So today we will be discussing the remaining part of the programming, that is part 2. We have already discussed the branching instructions, and we also discussed few programs related with the branching instructions. And today we will be discussing the complement operations, which is required for the 8-bit numbers, or ones complement or the twos complement form. So the first program which is going to be discussed in this video the first program is we have to find out the ones complement of the number which is stored at a particular memory location at 2000 is the memory location where 8-bit number has been written, and so the number which is stored at 2200 is the memory location, and we have to take the ones complement. So here we have a flow chart. First of all, the number which is stored at a particular memory location will be taken, loaded into the accumulator, and then we will take the complement of that. So we already know that whenever we have to do any arithmetic operation, accumulator is taken as the reference point. If it is a arithmetic operation which involves two numbers, so one of the operand must be available in the accumulator. But if you have to do any logical operations or arithmetic operation in which it is a unary kind of operation which requires only one data to be operated on, in that case also that number must be available in accumulator. So जो कोई किसी भी नंबर का हमको कॉम्प्लीमेंट निकालना होता है, ये जरूरी है चाहे वो रजिस्टर में स्टोर हो, चाहे वो मेमोरी लोकेशन में स्टोर हो. What we have to do, we have to copy, we have to load that number जिसका हमको वंस कॉम्प्लीमेंट निकालना है, we have to load that number into the accumulator first. Here in this problem, it is mentioned that the number for which we have to find out the ones complement is available at a memory location 2200. And after doing the ones complement, we have to store the complemented number at 2300. So at 2200, we have a number 55, and the result has to be stored at 2300. So first of all, what we will do, we will take the number, and then we will do the complement of that number, and then we will do the we will store the result, and then it will be the end of the program. So whenever we have to get the number, so we will be using an instruction LDA 2200, because we know that the number is available at a memory location 2200. So we get this number into the accumulator. So by using this instruction, we are able to load an 8-bit number which is available at the memory location 2200 into the accumulator. And then we take the complement of that by using an instruction CMA. CMA instruction will do the complementation process of the accumulator content. Since the number is already available in the accumulator, so it will do the complementation. So once it will do the complement of the number which is available in the accumulator, it will also store the result into the accumulator itself. So the result after doing the complement, the result will be stored in the accumulator. Now what we have to do, we have to copy that result somewhere in the memory location as mentioned in this statement 2300. So what we'll do, we will use instruction STA 2300, which will be used to store the result. So whatever is available in the accumulator, it will be copied into the memory location at 2300 and then halt the program. Program is finished. Now, if you have to get the 2's complement of the number, and that number is available at the same memory location 2200, and after doing the 2's complement, you have to store the result at 2300. So this is, I'm talking about the second problem. So first of all, what we'll do, we will start the process, get the number, take the complement, then add 1, because we know that the 2's complement can be formed by taking first 1's complement and then add 0, 1 into that. After adding 1, whatever we will be getting, that will be the 2's complement. And after that, we will store the result and end the program. So it will, the second problem will go in the same way as the first one. Besides, we have to add another instruction by which we are going to add 0, 1 into the content of the accumulator. So first of all, we will load the number from 2200 into the accumulator, take the 1's complement, and then we will do addition process with ADI 01. And after doing that, what it will do, it will add 0, 1 into the content of accumulator, and the result will be stored in the accumulator. So after third instruction, after third line is executed, the accumulator will be having 2's complement of a number. And then we will store the result from the accumulator to 2300. And so we're going to store the result and stop the program. So in this way, the 1's complement and the 2's complement of the number can be found out. This is another process of programming that is called looping, counting, as well as indexing. We already know that looping is a process in which whenever we have to do certain operations in a continuous way, we have to repeat the same process many times, then that process can be obtained, can be done with the help of looping. Counting is a process in which we are in requirement of counting of the value. Suppose there are 10 numbers which are available, and we have to check that whether the number is positive number or the negative number. So the checking of the number, whether it is a positive number or the negative number, can be done one at a time. So counting is required because after checking the 10 numbers, you have to stop. So that's why we are in requirement of counting, that whenever you are going to test the first number, the count will be 1. When we are going to test the second number, the count will be 2. And so whenever you are reaching to the 10th number, when you test the 10th number, counting should be 10. So this is a process by which you are able to finish your programming process, because as per the problem statement, it has been given that you have to test 10 numbers. You have to test 5 numbers. So in case of 10 numbers, you have to make the counting in the form of 10 numbers. If you have to test 5 numbers, so count will be 5, like that. And indexing is a process of making the reference. Suppose, what is meaning by indexing? Indexing is the reference point. Now, if you take an example of a library has enormous number of books, sufficient number of books. And how to identify the individual book? It is being numbered. Individual book has been numbered, and the number which has been allotted to a particular book is called the indexing. Through the indexing, now in your notebook you do the indexing. Chapter number 1 in your textbook you have indexing in the very beginning. That chapter number 5 will start with 25 number of page. Chapter number 6 will start with 78 number page. Chapter number 10 will start. So it is just a reference point. So indexing is also required in the programming whenever you have to refer to a particular data which is available at a particular memory location. in the previous example, which I have given to you, that you have to test 10 numbers. So you must know where that 10 numbers are available. If these 10 numbers are available in a memory location, it must be designated by the address. So you must have a particular system by which you are able to designate the data which is available in the memory, and that designation can be done only with the help of the address of the memory where the data is residing. So for that purpose, we do the indexing. So first we start with the looping. Looping is a programming technique which is used to instruct the processor to repeat the task. Whenever you have to repeat the task many times, that can be done with the help of looping. Now, if you take an example which is given in the form of a flowchart, we start a process, we are going to perform a task, and then later on, we are saying that go back and repeat. So this task is being performed many times. First, it will start, perform the task, and then the instruction will be given to repeat the task. So this task is going to be repeated many times. So this is going to form a loop. So this is a process called looping. Now in programming, we use two kinds of looping. One is called continuous loop, another is called conditional loop. So continuous loop is the example which has been shown in the form of flowchart. It is a continuous loop in which the task is repeated continuously without any hesitation. But there are certain other loops which are called the conditional loop. Conditional loop are those loops which is going to repeat the task until the condition is met. It will going to repeat the task until the condition is met. But in continuous loop, it is going to repeat the task infinitely. But whenever we have to do the repeating of the task finite times, then there must be a certain condition. And if that condition is going to met, the task will not be repeated. Otherwise, it will be repeated. So that is why there are two kinds of loop, continuous loop and the conditional loop. Now here an example has been shown. Now, if we talk about the conditional loop is the repeating of the task until the condition is going to met. Now here, if I give an example in the form of flowchart, which is a figure number A, that shows that we are going to start a process, and then we are going to set up a counter for 500 laps. Go around the track, 1 lap completed, reduce count by 1 because we have a counter for 500 laps. We are going to go around the track. 1 lap is completed, reduce the count, and then we are going to check whether the 500 laps has been over or not. If it is not over, we are going to repeat the task, go again back, complete the second lap, reduce the count by 1, and again check whether the count has been finished or not. So this kind of loop is going to be repeated 500 times only until unless the counter is being exhausted up to 500. And every time counter, here the counter has been initialized by the 500. When the first lap is over, it will be going to reduce the count by 1 so that it will become 499. And this 499 is not a 0. And this task is repeated. Are the 500 laps repeated? Because 500 laps will be repeated when 500 is reduced to 499. 499 will be reduced to 498. 498 will be reduced to 497. And so the time will come when this count will be going to reduce to 0. So when it will become 0, then it means it has completed the 500 laps. And then when it is 0, it will say yes and it will stop. The same thing has been given here, that in which we have a counter for the 5 tasks, in which we are going to perform 1 task and then reduce the count by 1 and then check whether the count has become 0 or not. If it is not 0, we are going to repeat. If the count 0, no. If it is no, it will going to repeat. When again it will perform a task, it will reduce the count, it will again check whether the counter has become 0. And the time when this counter will become 0, it will come out of the loop. So it means these are the two examples of the conditional loop. Now, conditional loop is set up by conditional jump instruction. Here, we are going to put a conditional jump instruction. Jump on no zero. If the count is not zero, repeat, and when the count will become zero, go out of the loop. Similarly here, till the count is become zero, you are going to repeat, and when the count will become zero, it will go out of the loop. So these loops usually include counting, as well as these loop also includes indexing. What is indexing? I have already explained. One more thing which I have explained is the counter, and counter is set up by loading a particular number that is called count in a particular register, and counting is performed either by incrementing or by decrementing. अगर हमने काउंटर को इनिशियलाइज कर दिया है कि हमको 5 बार टास्क करना है, तो हमने काउंटर को 5 से इनिशियलाइज कर दिया है, तो पहली बार जब टास्क परफॉर्म होगा तो हम काउंट को रिड्यूस करेंगे तो ताकि वो 4 हो जाए, फिर टास्क को रिड्यूस करेंगे ताकि वो 3 हो जाए, फिर 2 हो जाए, फिर 1 हो जाए, और जब वो 0 हो जाएगा, सो counter can be used for either for incrementing process or for the decrementing process. And what is the meaning of indexing? Indexing means pointing or referencing an object such as data bytes which is available in the memory, and these data bytes are referred by a particular memory location, and referring a particular data in the memory by its location, by its address, is known as indexing. So for doing all this process, so we have certain additional data transfer instruction as well as certain arithmetic instructions which are used for the 16-bit operations. We have a few of the instructions we have already discussed, but right now it is the right time to discuss how it operates. The first instruction which works with the data transfer which comes under the category of data transfer instruction and used to work with the 16-bit of the data. The first instruction is LXI-RP 16-bit. The purpose of LXI-RP 16-bit is to load a 16-bit data in the register pair. This RP stands for register pair, and this register pair can be BC register, DE register, or HL register. And whenever we talk about BC pair, it is represented by B. Whenever I talk about DE pair, it is represented by D. Whenever I talk about HL pair, it is represented by HL, H. And whenever we talk about stack pointer, it is represented by SP. So with the help of LXI, any one of these register pair can be loaded immediately by the 16-bit number which is given along with the instruction. The second one in this category of the instruction is to copy the content of memory into the register. It is the data transfer operation from the memory to the MUPI, to the microprocessor. And for that, we can use an instruction move RM. What is the meaning of move RM? It is going to copy the data from the memory to the register. Which memory? Whose address is present in the HL pair. So HL pair is taken as the reference, is taken as the index and point where the address of the memory is residing, address of the memory is stored, and the memory address which is stored in HL pair, whatever is that address, and at that address, whatever is the content, it will be copied into the register. Now, a register can be any. It may be A, it may be B, it may be C, it may be D, it may be E, it may be H, it may be L. The second instruction which lies in this category is LDAX B/D. This LDX B/D stands for either we use B or we use D. It is a kind of an instruction which is going to load the accumulator indirectly. And how it is going to load the accumulator indirectly? It is going to load the content of accumulator by an 8-bit number. Which 8-bit number? From a memory. Which memory? Whose address is already present in the either in the BC pair or in the D pair. If I have written LDAX B, it means BC pair is containing a 16-bit address, and that address belongs to a particular memory location. And from that memory location, you have to copy an 8-bit data into the accumulator. The third instruction is LDA 16-bit. It is known as load accumulator direct. So what it will do, it is going to copy the content of the memory location into the accumulator, whose address is defined within the instruction as the 16-bit. So in this case, the first case is an indirect addressing. The second case is indirect addressing, but the third case is a direct addressing. So what I was talking about, that move RM is a kind of indirect addressing. BD is also, LDX is also indirect addressing. And LDA is a direct addressing in which the address is defined within the instruction. That is why it is called direct addressing. Now, the reverse of the case is also possible. The first one is move MR. Now, in this case, in the previous case, we were copying the data from memory to the microprocessor. Now, I'm trying to copy the data from the microprocessor to the memory. Now, there is one mistake here I have done. It is so move RM was to copy the data from the memory to the register, and move MR will be copying the data from the register to the memory, and the register will be definitely the microprocessor general purpose register. The second one is LDAX BD. Actually, here there is something wrong. It is not LDX, it is STAX. It is not LDX, it is STAX BD. The way by which we are copying the data from the memory whose address is present in the B and D or the D pair register into the accumulator. In the case of STAX, whatever is the content of accumulator will be copied in the memory whose address is defined in the either in the BC pair or in the D pair. And STA, here it is not LDA, it should be STA, STA 16-bit address, which is going to store the content of accumulator into the memory location whose address is defined by this 16-bit number. Now, there is another instruction which is used to load the 8-bit data directly into the memory by using an instruction MVIM 8-bit. By using this instruction, whatever 8-bit data you are going to define, this 8-bit data will be copied into the memory. But which memory? Again, it is an indirect addressing. Which memory? The memory whose address is present in the HL pair. And similarly, we have incrementing and decrementing of the register pair. That is INX RP, that is going to increment the register pair. And then DCX RP, it is going to decrement the register pair. So whatever is the first instruction, that is LXI RP, how it works. So if I have written an example, LXIH2050, actually this instruction is a 3-byte instruction. And the purpose of using this instruction is to load 2050 into the HL pair. And whenever it is being done, this is lower byte, it will be stored in the lower order register. This is higher byte, and this higher byte will be stored in the higher order register. So whenever we talk about HL pair, in HL pair, we have two registers, H and L. L will be set to be the lower order register, and H is set to be the higher order register. And whenever we talk about 2050 as a 16-bit number, 50 is a lower byte, 20 is the higher byte. So lower byte will be stored in the lower order register, and higher byte will be stored in the higher order register. So how it works? LXI H2050, if I have written, it means it is going to load the HL pair register. But this instruction is a 3-byte instruction. The code, machine code, or the hex code of LXIH is 21. And since this instruction is a 3-byte instruction, to store this instruction, we require 3 memory location, and that is why it has been written 21, 50, and 20. Why 50 is written first? Because it is a lower order. 50 is a lower order address. So first of all, whenever we work with 16-bit number, first we write the lower order address, lower order digit byte, and then we write the higher order byte. So in this case, 50 is the lower order byte, so 50, and then 20 is a higher order byte, so it is 20 later on. The same thing can be done instead. If we don't want to use LXI, we can use MVI instruction. By using this instruction, we can write MVIH20. It is a 2-byte instruction. Similarly, MVIL50. So by using this, H register can be loaded by 20 and L register can be loaded by 50. But the difference between this instruction and using 2 instruction is that this instruction requires only 3 byte, but this instruction, agar we are using these 2, it will be taking the 4 memory locations. So it is always better to use less number of the memory location. So this is just the comparison of LXI instruction and MVI instruction. Then we have a data transfer copy from memory to the using the same instruction, that is move RM, if we want to use that. But before we are going to use the instruction move RM, it is necessary that the HL pair must be loaded by the address of the memory where from where the data has to be copied into accumulator. So before we write move RM, we have to be very sure that HL pair is already loaded by the memory address of that memory from where the data has to be transferred into the accumulator. So it is necessary. So before using move AM, please be assured that your HL pair contains the address of the memory or not. If it is not, you have to do LXIH 2050 and then move AM. So this instruction will do, it will load 2050 in HL pair, and then move AM, what this will do, it will copy the content of memory whose address is present in the HL pair, that is 2050, into the accumulator. So whatever is the content of 2050, that is F7, it will be copied into the accumulator. The next one is load accumulator indirect by using LDXB. But before we use this instruction, you must be sure that your BC pair register must be loaded by a 16-bit address. And for that, we can use the instruction LXIB 2050, by which you are going to load 2050 memory address into the BC pair. And then if we write LDXB, it will copy the content of the memory whose address is present in the BC pair. Since BC pair is containing 2050, so it means 2050 memory location pe jo kuch bhi data hai, that will be copied into the accumulator. And the third instruction was load accumulator direct. Load accumulator direct says that LDA 2050. So here the address is given directly, so no need to take the reference. So whatever is the content of 2050, that is F7, that will be copied into the accumulator. So in this way, this works.